Hello, once again welcome to my channel. Today we are going to discuss about light dependent resistor, LDR, or it is also called photoresistor. So what is a light dependent resistor? So light dependent resistor is we can define the light dependent resistor as it is a device whose resistivity is a function of the incident electromagnetic radiation. That means it is a device whose resistance will be depending upon the electromagnetic radiation. Such type of device are called LDR or light dependent resistor. Hence, they are light sensitive device. They are also called photoconductors or photoconductive cells or simply photo cells or cadmium sulfate cell. So this is how we can define the LDR. So this LDR is a optoelectronic device and it is mostly used in light varying sensor circuits and light and dark activated switching circuits. So this LDR is mainly used in light varying sensor circuit and light and dark activated switching circuit. So it will be used for switching some circuit corresponding to the intensity of the light. So some of the applications will be mentioned here, that is used in camera light meters, street light, clock radios, light beam alarms, reflective smoke alarms, outdoor clocks, etc. So this sensor is used wherever we want to switch some device corresponding to the intensity of the light. So how the construction of this LDR? So the construction of LDR include a light sensitive material that is placed on an insulating substrate like a ceramic. Here we will be placed a light sensitive material on an insulating substance like ceramic. And the material is placed in a zigzag shape as shown in the figure in order to get the required power rating and resistance. So like this is if this is a ceramic material, it is coated with the light sensitive material and this will be divided in a zigzag manner. So it is divided into two portions, portion 1 and portion 2, and two ohmic contacts will be taken from here, that is two conducting wires as in the figure. So this zigzag shape is used to get required power rating and resistance, and the ohmic contact will be made either on the sides of the area. So actually this photo sensitive material coated on this ceramic disc is divided into two portions using this zigzag pattern, portion 1 and portion 2, in order to get proper power rating and resistance. So light dependent resistor are made from either this light sensitive materials are either cadmium sulfate or cadmium selenide. So it is called a cadmium cell. The first slide it is I said this LDR is also called cadmium cell because this photoresistive material is made up of either cadmium sulfate or cadmium selenide, and they are sensitive to light having wavelength 4000 Armstrong to 10,000 Armstrong, that is blue light to infrared. So which containing no or very few electrons. The property of this material is this material containing no free electrons when not illuminated. So the characteristics of this material, this semiconductor material, this is a cadmium sulfide is a semiconductor material, and its property is there is no free electron, so it will be act as a insulator or a high resistive material when there is not illuminated. At this time, the resistance is as there is no free electrons, the resistance is also very high. When it absorbs light, the electrons are liberated inside the LDR, and hence the conductivity of the material increases with increase in the intensity of light. So here when light is absorbed, the electrons in the valence will be moved to the conduction band, and it will be act as a conductor, and hence the resistance is decreasing here. So the approximate relationship between resistance and luminance is give the relation R is equal to A into e raised to minus alpha, where R is the resistance and A and alpha are constant, and E is the luminance in lux. And the value of alpha is in between 0.7 to 0.9, and it is depending upon the material, depends upon the cadmium sulfide used. So this is how we can calculate the resistance. The symbol of LDR is shown in the figure. The two symbols are there. Either both the symbols will be used alternatively corresponding to some uses. So anyway, this is the basic symbol for the LDR. The structure of light dependent resistor is housed or it is packed in a clear plastic or resin case as shown in the figure here. It is to provide free access to external light. It is a clear plastic, top will be given. It is used for access of free access of the external light. Practical light dependent resistors are readily available in wide variety of size and package style. The most popular size of light dependent resistor having a phase diameter of roughly 10 millimeter. So this is the construction, this is a basic structure of a LDR or symbol used for the LDR. Then how LDR works? LDR or photoresistor. Photoresistor means it is depending upon the light. The resistance depending upon the light, or LDR is also light dependent resistor. Is made by any semiconductor material with a high resistance. As we say earlier, it is a cadmium materials are used. It has high resistance because there are few electrons that are free and able to move. The vast majority of electrons are locked. The crystal light is unable to move. That means it has high resistance because, as we see the energy band diagram, this is valence band and this is conduction band. It has high resistance because there is no electrons in the conduction band. Conduction band is empty. It is not filled. This band is, there is no electrons. No electrons in the conduction band. So it is not able to conduct, and usually the resistance is also high. Therefore, in this stage, there is a high LDR resistance. And when light falls on the semiconductor, what happens? And again from the energy band diagram, we can say that this is conduction band, so this is valence band, and this is conduction band. When light falls on these electrons will be absorb the energy from the light, and these electrons will be moved to the conduction band. And there are so many electrons will be moved to the conduction band, and conduction band is get filled by free electrons. So the conductivity of the material is increasing, and also the resistance is decreasing. So as the light falls on the semiconductor, light photons are absorbed by the semiconductor material, lattice, and some of their energy is transferred to the electrons. And this gives them to sufficient energy to break free from the crystal lattice so that they can conduct electricity. So these electrons will be absorbed energy from the light and move to the conduction band from the valence band. This results in the lowering of resistance of the semiconductor and hence the overall LDR resistance. That is, when LDR is kept in dark place, its resistance is high, and when it is kept in light, its resistance will decrease. So this is the property of the LDR or working of LDR. Here we see the variation of LDR resistance with the variation in light intensity. That means in a daylight, the resistance of LDR is in ohms, and at night the resistance will be in kilo ohms. And the graph shown below will be shows the relation between the resistance versus luminance curve. The graph will be show the relation between the resistance versus luminance curve for a particular light dependent resistor. At dark or a night time, the resistance will be very high, and at bright or a sunny light, the resistance will be very low. So this is a relation, that is relation between the resistance of LDR with respect to the luminance. There are two types of LDR materials are there. That is, first one is called intrinsic photoresistors and second one is called extrinsic photoresistors. Intrinsic photoresistors are called undoped or a pure semiconductor material including silicon or germanium. So photons fall on the LDR, exist electrons moving them from valence band to conduction band. Electrons will be moving from the valence band to conduction band. As a result, these electrons are free to conduct electricity. The more light that falls on the device, the more electrons are liberated and the generator, the level of conductivity, so greater the level of conductivity. And this result in lower level of resistance. So intrinsic photoresistors are pure semiconductor material. So materials used in this type of photoresistor, pure semiconductor materials are used, or undoped semiconductor materials are used. So extrinsic photoresistors are manufactured from the semiconductor materials doped with impurities. Semiconductor materials doped with impurities are called extrinsic photoresistors. These impurities or dopants create new energy band above existing valence band. As a result, the electrons need less energy to transfer to the conduction band because of smaller energy gap. So regardless of the type of light dependent resistor or photoresistor, both types exhibit an increase in conductivity or fall in resistance with increasing level of incident light. So both the type of material, the property is almost same, that while increasing the intensity of light, it will be decrease the resistance of the material. So what are the advantages of LDR? LDR are cheap and readily available in many size and shape. So cheap and it can be available in many size and shape. Practical LDRs are available in variety of size and package style. The most popular size having a face diameter of roughly 10 millimeter. They need very small power and voltage for its operation. So these are some advantages. The disadvantage, highly inaccurate with a response time of about tens or hundreds of milliseconds. So this is the disadvantage and disadvantage of LDR. So this is all about the LDR. I think you can clear what is an LDR. So thank you for listening me.